Have you ever wondered how closely multiple sclerosis and multiple myeloma are related, given their similar names? A valid question indeed, considering the common multiple in their names. But it turns out, despite their nomenclatural similarities, they are two distinct diseases, each with its own unique impact on the human body. Multiple sclerosis, or MS, is an autoimmune disease that assaults the nervous system, particularly the brain and spinal cord. It's like a rebellion within the body where the immune system turns against its own, damaging the protective cover of nerve fibers and causing a range of neurological problems. The name multiple sclerosis refers to the multiple areas of scar-like tissue, or sclerosis, that develop along the nerves. On the other hand, multiple myeloma is a type of cancer that primarily affects the bone marrow. It's a story of overproduction, where the body produces too many abnormal plasma cells. These rogue cells crowd out healthy ones, affecting the body's ability to fight infections and causing a host of other complications. The term multiple myeloma refers to the multiple areas of bone where these abnormal cells accumulate. Both diseases were named in the 19th century, a time when medical knowledge was still in its formative years. Multiple sclerosis was named by Jean-Martin Charcot, a French neurologist who was considered the founder of modern neurology. Meanwhile, multiple myeloma was named by Samuel Solly, an English surgeon, who first identified the disease after observing numerous tumors in a patient's bone. So, the story of these two diseases is a tale of two vastly different medical conditions, bound by a shared prefix and a common era of discovery. It's a tale of the body's own systems gone awry, whether through internal rebellion or overzealous production. As we delve deeper into this, we'll understand more about these unique diseases. Stay tuned as we navigate the intricate pathways of multiple sclerosis and multiple myeloma, shedding light on their histories, their impacts, and the ongoing research aimed at unraveling their mysteries. Multiple sclerosis, first discovered in the early 19th century, has an intriguing history. The journey to understanding this complex disease began with a French neurologist named Jean-Martin Charcot. In 1868, Charcot was the first to describe the distinct set of symptoms and the pathological characteristics of multiple sclerosis, thus laying the foundation for our knowledge of this disease. Throughout the late 19th and early 20th century, medical researchers started to piece together the puzzle. They recognized that multiple sclerosis was a disease of the central nervous system and that it involved an abnormal response of the body's immune system. However, the cause of this response remained a mystery. Fast forward to the mid-20th century, a time of great strides in medical research. A breakthrough came in the 1960s when a team of scientists led by Dr. Ian MacDonald developed the first diagnostic criteria for multiple sclerosis, allowing for more accurate diagnoses and better understanding of the disease's progression. Our understanding of multiple sclerosis has grown substantially since Charcot's time. We now know it to be an autoimmune disease, where the body's immune system mistakenly attacks the protective covering of nerve fibers in the central nervous system. This discovery has had far-reaching implications, not just in the field of neurology, but also in our understanding of other autoimmune diseases. The discovery of multiple sclerosis paved the way for a better understanding of autoimmune diseases. Moving on, let's explore the journey of multiple myeloma's discovery and research. Multiple myeloma, a type of blood cancer, was first identified in the mid-19th century. Initial understanding was rudimentary, with the disease often mistaken for other conditions. As medical science progressed, so did the understanding of this complex disease. The early 20th century saw researchers like Jan Waldenstrom delve deeper into the disease's pathology, shedding light on its unique characteristics. His work paved the way for further research, driving the medical community's interest in multiple myeloma. In the latter half of the 20th century, the advent of chemotherapy marked a significant milestone in the treatment of multiple myeloma. Researchers like Robert A. Kyle and Philip R. Gripe made substantial contributions to understanding the disease's behavior and progression, which led to the development of more effective treatment strategies. The turn of the 21st century brought about a revolution in the field of multiple myeloma research. The introduction of novel agents like proteasome inhibitors and immunomodulatory drugs, along with advancements in stem cell transplantation, have transformed the treatment landscape. Today, the focus of multiple myeloma research is on understanding genetic mutations and immune response and developing targeted therapies. The work of researchers like Dr. Kenneth Anderson and his team at the Jerome Lipper Multiple Myeloma Center and Libo Institute for Myeloma Therapeutics is pioneering in this regard. The journey of multiple myeloma research reveals the complexity and depth of cancer research. Now that we know how multiple sclerosis was discovered, what does modern science tell us about it? Multiple sclerosis, or MS, is now understood as an unpredictable, often disabling disease of the central nervous system. It disrupts the flow of information within the brain and between the brain and the body. The cause of MS is still unknown, but most theories suggest that it's a combination of genetic and environmental factors that lead to an abnormal immune response. In terms of treatment, the landscape has significantly improved over the years. We now have over a dozen FDA-approved disease-modifying therapies. These treatments aim to reduce the frequency and severity of MS relapses, slow the progression of disability, and manage symptoms. It's worth noting that while these treatments have been game changers, they are not a cure. Each person's journey with MS is unique and requires a personalized treatment approach. As for ongoing research, the field is vibrant and incredibly promising. Scientists are exploring new ways to stop MS in its tracks, restore function, and end the disease forever. They're looking at things like stem cell therapy, immunotherapy, and neuroprotection. These innovative approaches aim to repair damage to the nervous system and protect it from further harm. But how does this knowledge impact patients' lives? Well, with a deeper understanding of the disease and more effective treatments, people with MS are living longer, healthier lives than ever before. They are managing their symptoms, reducing relapses, and slowing the progression of disability. This means more time spent doing the things they love with the people they love. And yet, life with MS can still be challenging. The unpredictability of the disease can be stressful, and the physical symptoms can be difficult to manage. But the MS community is strong and resilient. They are not defined by their disease, but rather by their courage and determination. Despite the challenges, the future of multiple sclerosis research holds promise. With continued research and innovation, we can look forward to a future where MS is a thing of the past. In the same vein, what does today's research tell us about multiple myeloma? Multiple myeloma, a cancer of plasma cells, has been the subject of intense research efforts. Our modern understanding of this disease is a testament to the strides made in medical research. It's a complex disease where abnormal plasma cells multiply, overrunning the healthy cells in the bone marrow. This leads to complications such as anemia, bone damage, and kidney problems. In terms of treatment, we've come a long way from the past. Today, we have a range of therapy options at our disposal, including chemotherapy, targeted therapy, immunotherapy, and stem cell transplantation. Each of these treatments is designed to target the disease in a specific way, either by killing the cancer cells directly or by boosting the body's immune system to fight the disease. However, the research doesn't stop at treatments. Scientists across the globe are working tirelessly to unravel the mysteries of multiple myeloma. They're exploring new drug combinations, refining stem cell transplantation techniques, and investigating the genetic and molecular factors that drive the disease. These efforts are all aimed at improving outcomes and quality of life for patients. One particularly promising area of research is immunotherapy, which harnesses the body's own immune system to fight the disease. CAR T-cell therapy, for instance, modifies a patient's own immune cells to recognize and attack cancer cells. Clinical trials have shown promising results, and this could well be the next frontier in multiple myeloma treatment. Another exciting development is the use of precision medicine. By analyzing the genetic makeup of a patient's cancer, doctors can tailor treatments to target specific genetic changes. This could lead to more effective treatments with fewer side effects. The impact of this knowledge on patients' lives cannot be overstated. Better understanding of the disease means more accurate diagnoses, more effective treatments, and ultimately, better survival rates. Patients are living longer, healthier lives, and they're able to plan for their future with more certainty. The fight against multiple myeloma continues, and so does our quest for knowledge. From their discovery to the latest research, multiple sclerosis and multiple myeloma have indeed been a tale of two diseases. Our understanding of these conditions has grown exponentially over the years. We've traced the journey from the initial discovery of multiple sclerosis to the evolution of research into multiple myeloma. We've delved into the modern understanding of multiple sclerosis and explored the cutting-edge research currently being conducted on multiple myeloma. Yet, despite all our knowledge, there's still much to learn. The importance of ongoing research cannot be overstated. Every new study, every new finding brings us closer to unraveling the complexities of these diseases. It brings us hope for improved treatments, hope for better patient outcomes, and ultimately, hope for cures. As we continue to unravel the mysteries of these diseases, we take one step closer to a future where they can be more effectively managed or even cured.